All right, so the problem asks us to simplify 4x to the third, y to the fifth, times all of these things being raised to the third power, negative 3, x to the second, y to the second, all being raised to the third power. And for right now, we're still taking multiple choice tests, and so this problem appears to be about exponents and rules of exponents. In reality, the soul of the problem is this thing positive or is it negative? Because all you really need to determine, notice that this is positive 108 x to the ninth y to the 11th, and this is negative 108 x to the ninth y to the 11th. All you really need to determine is whether the answer is positive like this one or negative like this one. Over the next several years, the PARCC test is no longer multiple choice, and so test-taking strategies like this don't work anymore. But it will work for this. I want to determine if this is positive or negative, and so I count the negatives in this term. No. Okay, no negatives there. Well, I got a negative here, and I've got that negative to the third power. So whatever this is, I'm just going to call it z. This is negative z to the third power. Negative z, all being raised to the third power. And if I count the negatives there, that's negative z times negative z times negative z. That's 1, 2, 3 negatives, and that makes a negative. These two negatives make a positive. This one remaining negative, positive times a negative is a negative. If you have odd numbers of negatives, the answer is negative. Because when you're doing your calculation, every pair of negatives makes a positive. And, well, you've got an odd, so they pair off, and then there's one left over. And so odd numbers of negatives, like to the third, if you have an odd number of negatives, the answer is negative. And if it's an even number of negatives, the answer is, well, these pair off to make positives, and there's nothing left over. Every pair makes a positive, and so if you have an even number of negatives, 1, 2, 3, 4, 5, 6, every pair of these makes a positive, and so the answer is just positive. Evens are positive. All right, let's actually solve this now. And you can see that I've organized the problem at this point into coefficients or constants 4 times negative 3 to the third, and those are my black terms. I've organized them into x's, those are the red terms, x to the third times x squared to the third, and my blue terms, y to the fifth times y to the second to the third. I might as well solve this two different ways. I'll do it this way first. First, the black terms. 4 times negative 3 to the third. Negative 3 to the third. And now I'm going to do the red terms. X to the third times x squared to the third times x squared to the third. And then the blue terms. Y to the fifth times y squared to the third. Squared to the third. And in each one of these cases, I'm going to use the order of operations. So I'm going to multiply the coefficients here and here, multiply because of the rule that I'm using, the power to a power rule. And just like in the order of operations, I multiply before I divide. I multiply before I add and subtract. I'm going to multiply this times this before I add the 3 to it. And so that's 4 times negative 3 to the thirds. Let's do that last. 2 times 3 is 6. Let's use red. 2 times 3 is 6. X to the 6. And then the rule to multiply two exponents is to add. In the y's, 2 times 3 is again 6. I've got y to the fifth times now y to the second times y to the third is y to the sixth, and the rule for this exponent is to add. And then this, like I say, is really the soul of the problem, the coefficients, because you're actually going to have to multiply all those things. So that's negative 4, or rather positive 4, times, and then negative 3 3 times, negative 3 times negative 3 times negative 3. And my best advice is just to use a calculator for that. You get negative 108. All right, so the final solution is negative 108, x to the ninth, y to the 11th.